And so the title of my talk is Demazure filtration of tensor product modules of current Lie algebra of type 1. So there are lots of notions. I'll define each and everything and then present you the results. So here are the certain set of notations. And I guess almost all of you are familiar with these notations. So I'll first move to the motivation part, that how I got motivated for this problem. So the study of the indecomposable representations of affine Lie algebra has been of interest, and the theory has been started with this paper by Professor Vejanti Chari and A.N. Presley. They introduced the notion of the wild modules and to study the indecomposable but reduced representation of affine Lie algebra. So it was proved that it is enough to study the analogous modules for the current Lie algebra, which is denoted by this GT of a simple Lie algebra. And then our results are inspired by the question which is asked by Joseph Anthony, that if we have an integrable module and tensor it with a Demazure module, whether this admits a Demazure flag or not. So then many researchers worked on this problem by O. Matthew, P. Polo, and Callan proved that if we take the tensor product of two arbitrary Demazure modules, then it is not necessary that it has a Demazure flag. So then we looked at these modules for the G-stable Demazure module, and basically in the settings of the current algebra. And since the local while module is isomorphic to a level 1 Demazure module, so we study the tensor product of the two local while modules, which is basically the tensor product of two level 1 Demazure, and we try to create a filtration for the level 2 Demazure module, and we finally succeeded it. So the work is motivated by the conjecture given by Dr. Donna Blanton, that the tensor product of the Demazure module, so the conjecture was that the tensor product of Demazure module of level M and N have a filtration by Demazure module of level M plus N. So we proved this conjecture for the tensor product of two level 1 Demazure modules, and we give the filtration by level 2 Demazure modules. So first I'll define the notion of current Lie algebra. So let G be a simple finite dimensional Lie algebra, and you tensor it with CT. So you'll get a Lie algebra with the Lie bracket this. And then, so there's a notion of the local while module corresponding to this current Lie algebra. This acts as a universal module that because every finite dimensional integrable highest weight module is a quotient of this local while module. So then the local while for any lambda, for any dominant weight, we can define the notion of the local while module, which is a cyclic GT module generated by the cyclic module generated by this W lambda, and the defining relations are that the positive part will act as 0, and then H part will diagonalize it, and the higher degrees will kill it, and then this Y part. So and then there are, so since all the modules become the quotient of this local while module, so therefore then people started studying the quotients of the local while module, and there's a well-studied family which is the Demazure module of level L. So for corresponding to the positive dominant weight, the Demazure module of level L, dl lambda, it's a quotient of a local while module. So all the relations that we have studied for the local while module will be there, and then it's a quotient of local while module by a sum module generated by this. So there are certain extra relations in this. And then we can define the notion of Demazure flag of level L, that if we have a graded GT module, so then this representation has a Demazure flag of level L if we get a decreasing sequence of GT modules such that each quotient becomes isomorphic to level L Demazure module. So the level has to be fixed. And then there's also a notion of Chari Venkatesh module. So this is also a quotient of a local while module, and it's a beautiful notion which was introduced by Chari and Venkatesh. So I'll define it in case of SL2T, but this notion has been defined in general. So in my case, so if we take a partition, corresponding to every partition, we can define a module V lambda, which is a cyclic SL2T module generated by the vector V lambda. So all the local while relations will be there, and then there are certain extra relations which are known as XRS relation. So these relations, so we can identify them. For example, if we have a partition for 3, 2, 1, so then this module, so we can define our Chari Venkatesh module corresponding to this V 4, 3, 2, 1. And And why this is beautiful? Because the local while modules, Demazure modules, truncated local while modules, all of them becomes isomorphic to the Chari-Venkatesh module for certain partitions. So then there's a presentation of a local while module. So I have given the presentation of a tensor product of a local while module with a CV module, Chari-Venkatesh module. So I have defined a new module which is called WM lambda. And then if we consider it as a SL2T module, so this module is generated by an element, this. So I have created so this is a module generated by a vector along with these relations. So I have put the relations of both the modules. XRS relations whenever R plus S is bigger than this, and YRS relation, and then H tensor T raised to power R relation. So then I'll prove that the module that I have defined will actually be isomorphic to the tensor product of a local while module with a CV module. So to prove this thing, the natural strategy is to define a surjective map from this new module to the tensor product of local local tensor CV. And so the main idea here is because the tensor product is generated by the highest and tensor lowest weight vector. So we have defined a map from here to here, and then it's a surjective SL2T module homomorphism. So then the next thing is to prove that it's a well-defined map and it has to be injective. And I'll prove that it's an injective map by proving that the dimension of this module is less than the dimension of the tensor product. So this is the main step here, how to prove that the dimension of this is less than the dimension. So the proof is quite long, so I'll just include the idea of the proof, that it involves PVW theorem, Chari-Loktev basis, and basis of the CV module, and the dimension of both. So combining these 4 strategies, we can prove that the dimension is less. So this is the result, that the new module that we have defined. So this gives the presentation of the tensor product of the local while module with the CV module. Next thing is we study, so now we want to create a filtration in tensor product of a local while module with an irreducible module. So I have defined a notion which is called filtration by Visai modules, which is a CV module. So if you have any GT module, so then there is a decreasing chain of GT modules such that each quotient will become isomorphic to a certain CV module. And M Visai will denote the number of times each CV is occurring in the filtration, so then the result is, if we consider the structure local while module tensor with the irreducible module, so this has a filtration by these CV modules, which are of the form this. And the thing that you'll observe in this, that all the partitions are of hook shaped here. So basically, if I'll explain with the help of an example, that if you take a W local of 3 omega tensor with V2, so this has a filtration, the length will be the minimum of M and N. And then so these are the generators for UIs, and then each quotient will become isomorphic to these CV modules. And then the next main motive is to move to prove the conjecture that the tensor product of 2 local has a filtration by level 2 Demazures. So then we define, so this is a basis. This is the basis of CV module, which is defined by Chari and Venkatesh in 2015. So it's a basis of the CV module dependent on this set. And then we can identify the local while module as a CV of V1 raised to power M. And then what we have done is we have provided a ordering on this basis. So the ordering on this basis looks like, so we'll write the YRS relation in this format, and then the tuple I1, I2 to IM. So MT is the biggest one. And then if the number, so I is greater than J, if the number of factors are less in I rather than in the, as compared to the number of factors in J. And if the number of factors are same, then we'll move to the sequence. We'll start looking at the sequence from right to left. And this induces an ordering on this set, the basis of Chari Venkatesh basis. So this produces an ordering on this set. And then to compute the number of the graded elements, so we have used a Chari-Loktev basis. We have another basis on the local while module, which is Chari-Loktev basis, which was introduced in 2006. So we have used this basis to compute that the number of the L graded elements of weight this is equal to the coefficient of Q raised to power L in the polynomial M choose K of Q. So for example, if we take the W local of 4 omega, so this is how we'll provide an ordering on the basis that starting with the highest weight vector and then the number of factors. If the number of factors are same, we'll compare the degrees, and then if the compare the sequence, and then the 2 factor cases, and then the 3 factor cases. So then what the strategy is, will provide the filtration in terms of the truncated local while modules. And then because each truncated local while module is also a CV module and there's a Demazure filtration in that, so then we can prove that actually the Demazure filtration exists in the tensor product. So the truncated local while module is also one of the quotient of the local while module by an extra relation y tensor t raised to power n here. So if you have a local W local of m omega, and if we put an extra relation in this, truncate it, so we'll get a truncated local while module. And the main ingredient that we'll use in our result is the result by Chari, Wand, and Schender and Shireen, that if we have any partition, then the CV module has a Demazure flag of level L if the level is bigger than the first part of the partition. So then these truncated local while modules are isomorphic to a CV module, which was proved by Hoos and Littleman, that local while is this truncated local is isomorphic to CV, and by this given result, you can see that the level 2 filtration exists in such type of CV modules because 2 is bigger than the first part of the partition. So we'll provide a filtration by these modules in the tensor product of 2 locals. So this is the notion of the graded character, that so if we have a graded GT module, then we can also compute the graded character of that module. So now the main thing is to create the filtration in the tensor product of 2 local while modules. So the first thing we'll prove is the character of the tensor product of 2 locals in terms of these modules, a positive formula for these tensors. So the strategy that we'll use is, first we'll write the tensor character of the tensor product of 2 local in terms of the local while module. So in case of SL2T, it's an easy formula. We can compute it by using Perry formula because the character of local is same as the specialized McDonald polynomial at t equal to 0. So it's just like a product of 2 McDonald in terms of McDonald. So we can compute it using Perry formula. And then I've also computed the graded character of these truncated local in terms of the local while modules. And then we can compare them, and we have the positive formula for the tensor product of 2 local in terms of the truncated local. And because the Demazure filtration exists in these truncated locals, so we can actually create the filtration. So this is a result by me and my supervisor, Anushri Khandai, that if we consider an SL2T module, W local of n omega, tensor with m omega, so it has a filtration such that each successive quotient is isomorphic to a truncated local while module. And because each truncated one has a filtration by level 2 Demazure, so this module has a filtration by level 2 Demazure module. And the main thing that we have used is the character formula as well as the Chari-Loktev basis to actually create a filtration, that what should be the actual filtration in these modules, and the ordering on that. And the next thing that we have done is we have computed the multiplicity of the level 2 Demazures in the tensor products by writing the character of the truncated local in terms of the level 2 Demazure. So this is a positive formula. And then, so this result will actually help us to compute the Q multiplicities and what are all the weights that will appear in this tensor product, and what should be the and with what multiplicity. So this formula will actually give us the full information about the tensor product of 2 locals. And then because we have also worked out the local tensor irreducible case, so in case of local tensor irreducible, we have given the filtration by CV modules, which are of hook shape. And I have computed the multiplicity of each irreducible in the hook shape. So this gives us the multiplicity of each irreducible in the tensor product of local tensor irreducible. And the numbers are quite nice. So these are the multiplicities of each irreducible in the tensor product. So this helps us to write the, and what are all the weights that are appearing here. So this helps us to write the character of a specialized McDonald tensor with a Schur polynomial in terms of the Schur polynomial. So that's it. Thank you. And these are the certain references. So I have used the main references that I've used is the Chari Presley paper and Chari Loktev paper and Venkatesh, and this Jeff Wand, Chari Venkatesh. So Chari, Shireen, Jeff Wand. This is a 4-author paper by Demazure, flag and character formulas. And this is our paper, archive version of our. Thank you.
Questions, comments? Okay, if not, let's thank Divya again.